It is 6th lecture on projections of lines. We are going to solve few more problems on projections of lines in this video. Read this problem. The distance between end projectors of 80 mm long line AB is 40 mm. So in the first statement this information is true length 80 mm long line AB, true length, and distance between end projectors is 40 mm. So DBEP is 40 mm, distance between end projectors. End A is 15 mm above HP and 20 mm in front of VP. So in this case, end A is the reference point, a point whose position from both HP, VP given. So 15 mm above HP, that means it should be 15 mm above XY line front view, and 20 mm in front of VP, that is in front of XY line on drawing paper, it should be top view. The line is inclined at 30 degrees to the HP. So true inclination of line with HP is given 30 degrees. The line is inclined at 30 degrees, that is, it is true inclination with HP, that is why I have used notation theta. Draw projections of the line and find its inclination with the VP. Okay, phi you are asked to find, inclination with VP. But that after completing the drawing, you are just going to measure that angle with VP. End B is in the first quadrant. First quadrant means front view above. So front view above, top view below, you are going to take care of position of the other end. Here it is XY line, projector of end A, leave some space here for dimensioning, and then draw projector of end A. It should be exactly at 90 degrees to XY line. Then on the projector, carefully measure the distances and mark front view of point A and top view of point A. To all labeled points, there must be horizontal lines and also vertical lines. So through A dash, vertical line is of course there, that is projector of A. I have drawn horizontal lines. On this horizontal line, we already know that point B2 dash is, and on this horizontal line, we already know that this is line B1. If you are little confused with this, I recommend you to watch first two videos on projections of lines once again. When line is inclined to both the reference planes, in our final drawing there must be 6 views of the line, 3 front views and 3 top views. Check here, these are the 3 top views, AB, AB1, AB2, and 3 front views, A dash, B dash, A dash, B1 dash, A dash, B2 dash. Length and angle of line AB, length is PL, inclination beta. Length of line AB1 is PL and it is parallel to XY line. So we say horizontal PL. So actual PL, actual top view, horizontal top view, and AB2 is true length top view. That is, it has true length and inclination phi. Phi is true inclination with VP. A dash B dash is EL and angle alpha. A dash B dash has length EL, elevation length, and angle alpha. A dash B1 dash, that has true length and angle theta. And A dash B2 dash has a EL and it is horizontal, parallel to XY line, means on drawing paper it's horizontal. Top view, horizontal top view, and true length top view. Front view, true length front view, and horizontal front view. Check here, A dash B2 dash is always horizontal or parallel to XY line. That is why you know that on this line B2 dash is, because A dash B2 dash is parallel to XY line. Check here, AB1 has length PL and it is parallel to XY line. So AB1 is horizontal. Out of these 6 views, the view which you will able to draw using data directly by measurements, you should draw it. You must be able to bring all these 5 measurements on paper. So this is how we think. We know true length, we know angle 30 degrees. True length and theta. True length and theta are known, so we can draw A dash B1 dash. So we should measure that theta upwards because B dash must be above XY line. And you all know that B dash and B1 dash, B dash and B1 dash always lie on a horizontal line. So if B dash is above XY line, then B1 dash also must be above XY line. So measure 30 degrees in this manner, that is upwards. So measure 30 degrees and B1 dash we have marked. One more measurement is remaining, that is distance between end projectors. This is projector of end A. The other end is end B. So projector of end B is at distance 40 millimeters from projector of end A. So measure 40 millimeters and draw projector of end B. This is projector of end B. Here it is projector of end A, and distance between these two end projectors is 40 millimeters. It's given. This line is projector of B, means on this line front view of point B and top view of point B are. Point B is in third quadrant. That's why we are sure that front view of point B is above XY line and top view of point B is below XY line. Now watch here. This projector of end B intersects many other lines on paper. Not all these points of intersections are important or significant. Here it cannot be B dash because this line is at an angle theta 30 degrees. Remember, A dash B dash must have angle alpha, not theta. So this cannot be B dash. A dash and here it is B dash, impossible, because line is inclined to both the reference planes. So front view and top view both are inclined to XY line. This cannot be B dash. And of course this is not B2 dash also, because this is projector of end B and not projector of point B2. This is projector of point B and not projector of point B2. Okay. Right now, major work is over. When you bring all 5 measurements on paper, it means major work is over. Now remaining procedure, do you remember? Draw horizontal vertical lines through all labeled points, and when you are sure that there are horizontal vertical lines through all labeled points, use compass to rotate EL or PL. And if EL or PL are not available for rotation, then we should use true length to get a new point on paper. Remember, when you use compass, that you get always a new point. Through that point again you should draw horizontal vertical lines, and when you are sure that there are horizontal vertical lines through the new point also, then use compass again if required. Okay, that is our procedure properly. So through B1 dash I'll draw horizontal line and vertical line. So through B1 dash vertical line, which other point on this line? B1. So here it is B1. There is already a horizontal line we have drawn for B1. So we know where exactly B1 is. And AB1 is always PL. Remove this rough label. Now draw horizontal line through B1 dash. Which other point on that line? B dash. Do you have any other line for B dash? Yes, this vertical line is for B dash. So when you draw horizontal line through B1 dash, you will get B dash. We got B dash. Remove that rough label. Now join A dash B dash because it is the required front view. Now check in the diagram. There are horizontal vertical lines through all labeled points. What does that suggest you? To use compass to rotate either EL or PL. Now check here. This is EL. There are two ELs. One more view has same length EL, and which is that A dash B2 dash. This is front view of the line in given position. This is true length front view and horizontal front view. Horizontal front view is A dash B2 dash. So you can rotate A dash B dash, make it horizontal to get B2 dash here. A dash B2 dash horizontal. Or you can rotate top view also AB1, but of course this rotation is about the reference point. Rotate PL. Which other view has same length PL? AB. Is there any horizontal or vertical line for point B? Yes, on this line that point B is. So rotate AB1 downwards and get that point B here. But rotate either EL or PL. I am rotating EL, watch here. So I have rotated EL. So here it is B2 dash. Now through B2, check here, when you use compass you get a new point. So don't immediately start rotating PL. There is nothing wrong in that now if you rotate PL, but remember it's better to have one standardized procedure to solve the problem, so that you will able to solve problems faster, and not only that, if there is mistake you will able to rectify it immediately. So through B2 dash I'll draw vertical line. A dash B2 dash is EL. Which other point on this line? B2. B2 dash and B2 lie on the same vertical line. So on this line B2, is there any other line in the diagram for B2? No. So we will not get B2 immediately, but at least we are sure that on the projector of B2 dash, B2 is. Now there are horizontal vertical lines through all labeled points. That suggested you to use compass. Rotate either EL or PL, but EL rotation is already over. So now we should rotate PL. So rotate PL, AB1, PL, and AB also has length PL. So by rotating AB1, you will not get B2 here. You will get B. Be very careful about that. That is why these rough labels we use. These rough labels help you to avoid mistakes during the construction. So join A and B. What is that? Top view. So A dash B dash is front view and AB is top view. Is this drawing complete? Not yet. When you rotate PL, you got a new point. Now through this point, horizontal vertical line. Vertical line is already there. Now draw horizontal line through that point. Which other point on this line? B2 is. B and B2 lie on a horizontal line. There is already one vertical line for B2. It means we have found out B2. Join AB2, that is true length. AB2 is always true length and true length gives true inclination. Now this is true length in the top view. So top view gives details with respect to VP. So true length it is given. Phi, you measure this angle, you will find it as 45 degrees. You are asked to find phi. In the diagram, only these dimensions are to be inserted. 15, 20, 30 degrees. True length we always mention outside the diagram. And finally, you insert distance between end projectors. Read this problem. Plan and elevation of 75 mm long line AB measure 65 mm and 55 mm respectively. So in this first statement, we have this information. Line AB is 75 mm long and its plan measures 65 mm and elevation measures 55 mm. So TL, PL and EL given. As I told you, if line is inclined to both the reference planes, there will be 5 measurements given. These are the 3 measurements and of course the other 2 measurements are position of the reference point. Let's read. End A of the line is 15 mm above HP and 20 mm in front of VP. So here it is XY line. Projector of the reference point 15 mm above HP and 20 mm in front of VP. Draw projections of the line. Determine inclination of the line with the reference planes. So inclination of line with the reference planes. What do you mean by that? Inclination of line with HP, that is theta. True length front view A dash B1 dash will give you that angle. And phi is angle of true length top view. AB2 will give you that angle phi. Okay, so these angles are to be measured sim. Now position of the other end is not given. So when position of the other end is not given, then we should assume its position. So let's assume position of the other end in first quadrant, that is front view above, top view below. And let's proceed. Here it is XY line, projector of end A, mark A dash and A. A dash B2 dash is always horizontal. So on this line somewhere B2 dash is, and from point A or through point A a horizontal line is, and this is the line on which B1 is. A B1 is always horizontal. Now how we proceed? Out of 3 front views, A dash B dash, A dash B1 dash and A dash B2 dash, which front view you will able to draw? So A dash B dash has length EL, that is given, but its angle is not given, and that is why we don't know at what angle that A dash B dash is. So we cannot draw A dash B dash. A dash B1 dash has true length, that is given, but A dash B1 dash has angle theta, and that is also not given. So we cannot draw A dash B1 dash. Then can we draw A dash B2 dash? A dash B2 dash is horizontal and it has length EL. So yes, we can draw A dash B2 dash. So measure that length 55 millimeter and here it is B2 dash. It has length EL which is given 55 millimeters. Similarly through point A, AB1 we can draw. AB1 has length PL. AB1 is always horizontal V. So I measured 65 and I have marked B1, AB1. AB2 we cannot draw. AB2 has true length. Top view with suffix 2 is true length. AB2 is 75 millimeter but angle is unknown. And then AB, top view, that has length PL, it's given, but top view if you want to draw directly, you must know beta, inclination of top view, and that is not given. So out of 6 views, these 2 views we could complete, A dash, B2 dash and AB1. And in this process, we have brought 4 measurements on paper. Check here, 15, 20, 55 that is EL and 65 that is PL. Insert dimensions after completing the drawing, remember. Okay. So how to bring true length on paper? Remember, true length you can directly draw if you know the angle, because true length always gives true inclination. So right now we cannot bring true length on paper, but we'll proceed. And what is our procedure? Through the label points, draw horizontal vertical lines. Through B1, draw vertical line. Which other point on this line? Obviously B1 dash, because it is top view, so front view of the same point. Why I didn't extend it downwards? Because we are sure that B1 dash is above XY line. Why we are sure? B dash is above XY line. Now through B2 dash, draw projector, and on this line obviously B2 and B2 dash, front view and top view on same vertical line. Somewhere on this line B2 is. Now there are horizontal vertical lines through all labeled points. Check in your diagram. So use compass and rotate either EL or PL, but listen to me very carefully. Right now EL or PL are not available for rotation. The reason is, which other view has length EL? A dash B2 dash has length EL. Which other view has length EL? That is A dash B dash. A dash B dash has length EL. So by rotating A dash B2 dash, we should get A dash B dash. But have you realized in your drawing right now there is no a single line for B dash. There is no horizontal line for B dash. There is no vertical line for B dash, and there is also no inclined line for B dash. So right now there is no any single line on paper on which point B dash is. So if you rotate A dash B2 dash, you will complete a circle, but you will not get B dash. That is why I say that EL is not available for rotation. Similarly PL, right now if you rotate AB1 about point A, you will not get B point. Which other view has same length PL? AB. So by rotating AB1, you don't know how much that AB1 is to be rotated for point B. So you will not get point B. So don't rotate EL or PL at this stage. Then what to do with compass? When a rotation of EL or PL does not give you any new point, then we should use a true length. So now take true length in compass. How much is that? 75 millimeters. So take 75 millimeter true length in compass. Tell me which view has true length? A dash B1 dash, and there is line for B1 dash. And also AB2, here it is point A, and on this vertical line B2 is. So top view with suffix 2 has length, true length, that is 75 in this case. So now use true length in this way. Through A dash, because we know that B1 dash is on this line and A dash B1 dash has true length, you cut it. So this is how we have marked B1 dash. A dash B1 dash is true length. So when you use compass, you always get a new point. So leave compass immediately once you get that new point and draw horizontal vertical line through the newly marked point. So B dash and B1 dash always lie on a horizontal line, and that is why we know that on this line somewhere B dash is. Now again you will find there are horizontal vertical lines through all labeled points. So we should use compass. Rotate EL, because on this line B dash is. Which other view has length EL? A dash B dash, and you know now horizontal line for B dash. So up to that line you rotate A dash B2 dash to get A dash B dash. Now if you join A dash B dash, it will be front view of the line. Now when you use compass, you get a new point again. So leave that compass and through B dash draw vertical line again. So on this line somewhere point B is. We are sure about that. Now check once again. There are horizontal vertical lines through all labeled points. So now again use compass. But now you should rotate PL, because EL we have already rotated. Now you should rotate PL. Which other view has same length PL? AB. Is there any line for point B? Yes. So rotate PL and you have found out B. Now join A and B. So this is top view. Now through B draw horizontal line and you will get B2 here. B and B2 always lie on a horizontal line, and this is the vertical line for B2. Here it is B2. Join A, B2. And what is that? True length. If you measure this length A, B2, you will get it 75 millimeters. Okay. So we have completed the drawing. Now we should insert all dimensions. If any dimension is asked, we'll measure it in our diagram. So let's insert the dimensions. TL 75. This angle is theta, you are asked to find out. And this angle is phi here, you are asked to find out. A dash B1 dash. True length front view gives inclination with HP, and true length top view, that is AB2, gives inclination with VP. Read this problem. A line AB has true length 115 millimeters, but it appears 75 millimeter long in front view and 105 millimeter long in top view. And A is 70 millimeter above HP and 10 millimeter in front of VP. Write this information in paper properly. True length 115, but it appears 75 millimeter long in front view and it appears 105 millimeter long in top view. End A is reference point. Position of end A is known from both the reference planes. What is that position? 75 millimeter above HP. So we should measure 75 millimeter above XY line, and front view gives distance from HP. 10 millimeter in front of VP. So 10 millimeters in front of XY line, point A, that is top view of point A. Draw projections of the line and find its true inclinations with the reference planes. End B is closer to the HP and behind VP. So information about end B is given in this manner. It is closer to HP. Which view gives details with respect to HP? Front view. So end B is closer to HP. It means B dash must be closer to XY line. It can be above XY line, it can be below XY line. That depends. When we'll complete the drawing, we'll come to know about that. But what is very important, B dash must be closer to XY line. And it is behind VP. What do you mean by behind VP? Top view above XY line. Check. B dash is closer to XY line, but right now we are not sure whether it is above XY line or below XY line. Now let's proceed. Here it is XY line. Draw projector of point E and label point A. So here it is top view of point A and here it is front view of point A. Draw horizontal lines through A dash and E. On this horizontal line B2 dash is, and on this horizontal line B1 is. We always know it. A dash B2 dash is horizontal front view and A B1 is horizontal top view. Now through A dash there are 3 front views. Out of those 3 front views, from this data, EL, horizontal front view, will able to draw. So this is A dash B2 dash. True length front view, we cannot draw. Even if we know true length, we don't know theta. So A dash B1 dash we cannot draw, and A dash B dash has length EL and angle alpha. We cannot draw A dash B dash right now, because even if we know EL, we don't know alpha. So similarly, out of 3 top views, you will able to draw only horizontal top view that has length PL 105 millimeter and it is V1. So this is how we have brought that information on paper, but still true length we have not measured in our drawing. Which view gives true length? A dash B1 dash, but we don't know that angle theta, and also AB2 gives true length, but we don't know that angle phi, so we cannot draw AB2. Okay, now through all labeled points draw horizontal vertical lines. So through B2 dash and through B1 we'll draw horizontal vertical lines. So through B1 horizontal line is already there, now here it is vertical line. Which other point on this line? Obviously B1 dash. Through B2 dash vertical line. Which other point on this line? Obviously B2. Two views of a point lie on the same projector. So when you are sure that there are horizontal vertical lines through all labeled points, then use compass and rotate either EL or PL. But in this case, if you rotate A dash B2 dash, which other view has same length EL? A dash B dash, of course. But there is no any horizontal or vertical line or inclined line for B dash. So how much you will rotate EL? We don't know. So don't rotate EL. Same thing with PL also. AB1, which other view has length PL? AB. But is there any horizontal or vertical line for B? No. So you cannot rotate PL at this stage. So when EL and PL are not available for rotation, then you should use true length. Which view has a true length? A dash B1 dash, and we know that on this line somewhere B1 dash is. So take true length in compass. So I have taken it in compass, and from A dash I'll cut this line. This is the line on which B1 dash is. So here. Now this is very important. When you cut it, check here. We know that B1 and B1 dash lie on the same projector. So on this line B1 dash is. But when you cut this line with true length, it cuts this vertical line at 2 positions. So which is the correct position of B1 dash? Is it B1 dash or here it is B1 dash? So check the information. It is clearly given that B dash is closer to XY line. B dash is closer to XY line, that means B1 dash is closer to XY line. So we should choose this point as B1 dash and not here. So here it is B1 dash. Label it and draw true length. A dash B1 dash is true length. On this line somewhere point B dash is. B dash and B1 dash lie on a horizontal line. Now there are horizontal vertical lines through all labeled points. So use compass and rotate EL. And we got B dash. Join A dash B dash. A dash B dash, that is actual front view of the line. Now when you use compass, you get a new point. Here in this case B dash. Now draw vertical line through B dash. Which other point on this line? B. So somewhere on this line point B is. B dash and B on same vertical line. I have not extended that downwards because it is clearly mentioned that B is above XY line. So on this line I have extended that line upwards only. So on this vertical line somewhere point B is. Now rotate AB1. AB1 has length PL and AB also has the same length PL. And B is above XY line. So rotate AB1 above XY line to get point B on the projector of B dash. And here it is point B. Join A and B. So this is top view AB. Now you have used compass to rotate PL. You got a new point again. Now through new point you draw horizontal line for B2. And there is already vertical line for B2. Remember, B2 dash and B2 lie on the same vertical line. So here it is B2. Join AB2. That is true length. Now watch this diagram very carefully. Drawing is ready. How will you come to know? There must be 3 front views and 3 top views. So check through point A, AB, AB2 and AB1, 3 top views. Check here A dash, B2 dash, A dash, B1 dash and A dash, B dash, 3 front views. Note here B dash and B1 dash on the same horizontal line. B and B2 on the same horizontal line. Then check here, B dash is closer to XY line, B dash, check here, end B is closer to HP. So when it is mentioned that end B is closer to HP, it is comparison between the two ends. Check here, end A dash and end B dash. Which is closer to HP? Front view gives distance from HP. So B dash is closer to HP and point B is behind VP. Yes, behind VP means on drawing paper behind XY line. So our drawing is perfect. We have solved the problem. Find true inclinations with the reference planes. True length gives true inclination. So where is true length? A dash B1 dash is true length. And A dash B1 dash gives angle theta. And AB2 is true length. AB2 that gives angle phi. Now write these answers outside the diagram. And as usual, you should write true length. And as usual, you should write true length outside the diagram. So true length is 115. Theta, this angle, is 24 degrees. And phi, this angle, as 49 degrees. $75 millimeter. It is EL and PL 105 millimeter. All given dimensions you should insert properly in your diagram. So this is how your diagram will appear on drawing paper. Read this problem. Elevation of a line measures 85 and plan measures 70. So EL is 85, plan is 75 millimeter. The line is inclined to VP by 30 degrees. Phi is 30 degrees. Draw projections of the line if one of its ends is in the second quadrant 35 millimeter and 10 millimeter from HP and VP respectively. What do you mean by that? Distance from HP is 35 millimeters and distance from VP is 10 millimeter, and both these distances are to be measured upwards because the point is in second quadrant, means both views are above XY line. Check here, A dash and E, both views above XY line. So these are the 5 measurements. The other end is in the fourth quadrant. It's not mentioned that it is line AB. We have labeled this line as line AB. So one of its ends, this is how it is mentioned. So we have considered that end as end A. And the other end means that end B, and it is in fourth quadrant. That means both views below XY line. So B and B dash both below XY line. So now we'll proceed. Draw XY line. Label immediately XY line. Draw projector of the reference point. Mark the reference point. So 35 millimeters and 10 millimeters for front view and top view of point A respectively. And through the label points, draw horizontal lines. Which other point on this line? B2 dash is. Which other point on this line? B1 is. Now out of 3 views through A dash, B dash, A dash B1 dash and A dash B2 dash, we can draw A dash B2 dash because EL is given. So I'll draw A dash B2 dash. A dash B2 dash EL, that has length 85 millimeters. So here I have marked B2 dash. You cannot draw A dash B1 dash. To draw A dash B1 dash, you should know true length and theta. And you cannot draw A dash B dash also. To draw A dash B dash at this stage, you should know EL and angle alpha. Okay. Through A there are 3 top views. AB has length PL and angle beta. Length PL is given but beta is not given. We cannot draw AB. Then AB1 is parallel top view. Horizontal top view. AB1 length PL. So we can draw that. So you must have understood, if you know EL and PL, horizontal views you will be able to draw easily. So it's B1. And AB2, 3 top views. AB1 parallel top view, that we could draw because PL is given in the problem. Then AB2 is true length top view. So true length is not given. but angle is given. True length gives true inclination. So AB2 has angle phi. This is very important to remember all these 6 views, how we label those views and its length and angle in terms of notations. You remember that. Through AB2 has true length and true angle 30 degrees. True length is not given, but when only angle of a view is known, if angle of a view is only known, say at least draw a line at that angle. I have measured this angle downwards because the other end is below XY line. That's given in the problem. So here I have measured that angle 30 degrees, that is phi. And on this line somewhere B2 is. AB2 is true length showing true inclination, but that true length is unknown. That's why we could not confirm position of B2. So here I have mentioned that on this line somewhere B2 is. Have you brought all measurements on paper? Yes. 10 and 35 here, this phi angle 30 degrees here, and then EL 85 we have measured here and PL 70 we have measured here. When we have brought all 5 measurements on paper, what does that mean? Now by drawing horizontal vertical lines and using rotation of EL PL, we will able to complete the drawing. So let's proceed. What is the procedure? Through labeled points, there must be horizontal vertical lines through A and through A dash. Already there are horizontal vertical lines. Now through B2 dash and through B1, we should draw vertical lines. Horizontal lines are already there. When you draw those vertical lines, you know which are the other points on those lines. So through B2 dash, I have drawn vertical line. Which other point on this line? B2. And there is already one more line on the paper that has a B2 on it. So this point is B2. So we have marked B2. That means we got the true length of the line. What is that length? AB2, true length. Okay, but we'll proceed now. Through B2, draw horizontal line. Somewhere on this line, point B is. Are you going to use compass? Not yet. Unless there are horizontal vertical lines through all labeled points, don't use compass. So through B1 vertical line. Which other point on this line? B1 dash. There is no other line on the paper on which B1 dash is, and that is why we should just label this line as the line on which point B1 dash is. Now there are horizontal vertical lines through all labeled points, so use compass. Rotate either EL or PL. Here it is a PL, AB1. Which other view has same length PL? AB, and that is why we know that up to this line, because on this line point B is, we should rotate AB1. Now what about EL? Can we rotate EL? Check here, A dash B2 dash. It is EL, 85 millimeters. Which other view has the length A dash B2 dash EL? A dash B dash. Which other view has same length EL? A dash B dash. Now, is there any line, vertical or horizontal line for B dash? So, no. So, right now EL is not available for rotation. If you start rotating A dash B2 dash at this stage, you will get a circle but not B dash. Therefore, we have no choice, we should rotate PL. So, rotate AB1. And here it is point B. Join AB, that is top view. This is how we have completed top view of line AB. We got a new point. So through B point, draw vertical line. Somewhere on this line B dash is. I am not unnecessarily extend this line beyond XY line. The reason is both B and B dash are below XY line. So on this line B dash is, and of course it is below XY line. Now rotate EL. Because on this line point B dash is. And here it is B dash. Join A dash B dash carefully. That is front view. Now through B dash draw horizontal line. When you use compass you get a new point. In this case it is B dash. Through B dash draw horizontal line. For B1 dash, B dash and B1 dash lie on the same horizontal line. So this point is B1 dash. Join A dash B1 dash, that is true length. Is this drawing complete? Let's check it. A dash B2 dash, A dash B1 dash and A dash B dash. There are three front views. B dash and B1 dash on a horizontal line. Through A there are three top views, A B1, A B2 and AB. B and B2 are on the same horizontal line. So this is how we have completed the drawing. Now what is asked in the problem? True length. So true length, which view gives true length? Either you measure A dash B1 dash or you measure A B2. Both lengths are true lengths. It's same length. You should get the same length for A dash B1 dash and A B2. Out of these two, any one length you measure and you should write it as answer. One more thing. Find true length and true inclinations of the line with HP. What is true inclination with HP? Which view gives inclination with HP? A dash B1 dash. A dash B1 dash has angle theta. So let's write all our answers. 85 millimeter, given dimensions we are inserting. Then 70 millimeters, this length AB1 I have inserted. 10 and 35 here, and this angle 30 degrees. All given dimensions first you insert, and whatever asked in the problem you write nearby the diagram. So this is true length, measure it and write outside the diagram. A dash B1 dash is also true length. Of course it should get you should get the same length for A dash B1 dash and AB2. True length is 98 millimeters and theta is 44 degrees. This true length A dash B1 dash gives inclination with HP. So finally this is how your drawing will appear on paper. Now read this problem. End projectors of a line are 50 millimeters apart. End A of the line is in second quadrant, 25 and 10 millimeter from HP and VP respectively. End B is in third quadrant, 30 millimeter from both the reference planes. Draw projections of the line. Find its true length and true inclinations with the reference planes. What is the information? DB EP is given 50. End A is reference plot. 25 millimeters and 10 millimeters from HP and VP respectively. It's already given that end A is in second quadrant, that's why you should measure these two distances above XY line. So check A dash and A both above XY line. What do you mean by that? Point A is in the second quadrant. End B is in the third quadrant, that means top view above, front view below. But projector of end B is 50 millimeters from projector of end A. And end B is top view above, front view below. It is third quadrant, means top view above. So check, there are 5 measurements: 20, 10, 50, 30 and 30. Distance between end projectors means distance between projector of A and projector of B. It's given. So this is the information or data. Let's draw. You must be able to bring all these measurements on paper and very easily will be able to bring it. Here it is projector of reference point. And one more thing. Reference point is a point on the line whose position from both the reference plane given. In this problem, there are two such points whose position from HP and VP given. So when more than one points have their positions known from HP and VP, then any one of those points you can consider as a reference point. So we have chosen point A is a reference point, not a B. When more than one points are there whose position from HP VP given, then any one of those points you should choose as reference point. So we have considered A as a reference point. So let's label first a reference point. Since second quadrant, so I measured 25 and 10, both distances above XY line, to get front view and top view of point A, both the views above XY line. So point A is in second quadrant. Now through A horizontal line, B1 is on this horizontal line. Through A dash horizontal line, B2 dash is on this line. Now you cannot draw A dash, B dash, A dash, B1 dash, A dash, B2 dash directly because EL, PL, TL not given. Then what is the information? You have projector of B at distance 50 millimeters from projector of A. So draw that projector at distance 50 millimeters. So this line is projector of B, means on this line point B and point B dash are. So let's mark B and B dash 30 millimeters and 30 millimeters on both the sides. But top view above, because point B is in third quadrant. So here it is B dash. Now join A dash, B dash. This is front view. And join AB, and this is top view. So projections of lines are completed. You are asked to draw projections of the line. So without any extra construction, from the data itself, we got AB top view and A dash, B dash front view. Then is it complete drawing? Not yet. Have you realized you are asked to find true length and true inclinations? So remember that when line is inclined to both the reference planes, draw all the 6 views. Which are the other views? A dash, B dash is ready. Through point A dash, there are 2 more views. A dash, B1 dash and A dash, B2 dash. Similarly, through point A, we have already drawn top view of the line AB. 2 more top views are there. AB1 horizontal top view, check here, and true length top view AB2. So draw horizontal vertical lines through labeled points. So through B horizontal line. Which other point on this line? B2. B and B2 lie on a horizontal line. Through B dash horizontal line. Which other point on this line? B1 dash. B dash and B1 dash lie on a horizontal line. Now AB is PL. You can rotate AB, PL, and A dash, B dash is EL. Now if you rotate AB, PL, which other view has same length PL? AB1, and B1 is on this line. So let's do that. So I'm rotating AB. So here it is AB1. Now you got a new point. So you should draw horizontal vertical lines through the new point. So through B1 vertical line. Which other point on this line? B1 dash. Join A dash, B1 dash. That is true length. Next, rotate A dash, B dash. Length A dash, B dash is EL. Which other view has length EL? A dash, B2 dash. So make that horizontal A dash, B2 dash. So here it is B2 dash. Remove that rough label. So A dash, B2 dash is a parallel front view, and through B2 dash now draw vertical line, and you will get B2 here, because this is the line for B2. B2 and B2 dash on a vertical line. That is why you should draw vertical line through B2 dash up to this horizontal line of B2, and you have found out B2. Remove that rough label. Now join AB2. This is true length. So this is how we have completed the drawing. Now insert the dimensions carefully. So this distance of point B is given 30 millimeters. This distance of point B dash is given 30 millimeters, and distance between end projectors 50. So given dimensions you should insert in the diagram, and what is asked in the problem? True length and true inclinations. So for true length, either you measure AB2 or you measure A dash, B1 dash. AB2 gives angle phi. A dash, B1 dash gives angle theta. So measure true length, theta and phi. This is angle phi, which is 13 degrees. This is how the drawing will appear on paper. So we have solved about 5 problems in this video. You must have realized that basic procedure is bring all 5 measurements on paper using that 6 views logic, horizontal vertical lines through labeled points, rotate EL, PL, and if you don't get any extra point by rotating EL or PL, then you should use true length. But when you use compass, certainly you will get one extra point and then proceed as usual with horizontal vertical lines and rotation. This is how we complete very mechanically problems on projections of lines. And whatever information is asked, for example, find true length, find true inclinations, you can measure in the drawing. Simple. Okay, in our next video, we'll solve some more advanced problem on projections on line. Till then, bye bye. Thank you.